Hello students, welcome to the Turito School Foundation program. Today we are going to deal the very interesting topic, that is dimensional formula and applications of the dimensional formulae. In what way does we can use the dimensional formula to obtain the relation among the base quantities, right? For the 8th class students, we would like to go for that dimensional formulae and the applications, all right? We would like to go for that. Just we have to see, this is very clear. We would like to go for that the representation of dimensional formula. You can take that. Representation of dimensional formula. Yes, you can take that. That is going to be identified m power plus or minus a, l power plus or minus b, t power plus or minus c. This is very clear. We would like to go for this one. Okay, instead of that, if you are going to take that any derived quantity that can be represented as that m plus or minus a, the powers of base quantities have been raised to represent a derived quantity. It's okay. Instead of, you have to take that mlt, a, b are going to be the powers of base quantities. It's very clear. We would like to go for that. Okay. Now we would like to represent that ABC values and base quantities M, L, T, yeah, all together are useful to represent the dimensional formula. All right, it's very clear. Suppose if you are going to get that dimensions of mass, A is going to be the dimensions of mass, B length, yeah, you have to take this one. This is very clear. We would like to go for that. Right. Okay, if in the given problem, what they are supposed to ask, you have to take that. Instead of M, L, T, they have taken the base quantities. Yeah, force, acceleration and time are used as a fundamental units. Okay, it's very clear. The dimensional formula for the length, yes. So here you would like to get that fundamental units. You have to get that they have been taken that force, acceleration. Yeah, you have to take that. That is very clear. This is going to be the acceleration and time. Yes, you have to confirm force, acceleration and time. It's very clear. You would like to go for that. Force, acceleration. It's very clear. You can take that. Yeah, you have to use this F, A and T. Okay. So you can get that in this given problem. You are supposed to find out the dimensional formula of the length. If you have been used that base quantities, that is going to be force, acceleration and time. Okay. All right, you have to take that L is equal to, yeah, you have to write down, that's very clear, F power x, all right, A power y, all right, T power z. It's very clear. If you are going to represent in terms of that F, A, T, you can have to get this one. It's very clear. Yeah, you have to talk that. All right, that is very clear. You have to go for that. You know, that is mlt minus 2 power x, yeah, we have to use this, and lt minus 2, it's okay, power y, and t power z. It's very clear, we can go for this one. So if you are going to get this one, m power x, l power x, t power minus 2x, and l power y, t power minus 2y, and t power z. It's very clear. You have to get this one. That is, if you are going to expand this, and you have to write down the similar terms which are going to be the powers added, all right. So you have to confirm this is going to be the m power x, l power x plus y, and t power minus 2x minus 2y plus z. It's very clear. We would like to go for this one. This is going to be m power 0, l power 1, t power 0, all right. We have to confirm this one. This is going to be that l power 1. It's very clear, you would like to go for this, all right. Now we can go for that, yeah, compare that powers, you have to get that powers of the base quantities. Then we can solve the problem, it's easy for you, all right, you can go for this one. Yes, after that comparison, just you have to write down, that is very clear, yeah, you have to get that m power 0 is equal to m power x, so x is equal to 0, it's very clear, all right, yeah, l power 1 is equal to l power x plus y. So x plus y is equal to 1. So you will get that y is equal to 1. All right, x is equal to 0. That is very clear. 0 plus 1. Therefore, y is equal to 1. Already you got this one. And if you are going to get the next one, that is t power 0 is equal to t power, individually you have to compare, that is minus 2x minus 2y plus z. Okay, yeah, you have to get that minus 2x minus 2y plus z is equal to 0. You have to take this one, right? It's very clear. So you can get, for already we have that x is equal to 0. It is very clear. 0 minus 2y plus z is equal to 0. Yeah, y is equal to 1. Then if you substitute y is equal to 1, then easily you will solve that. Just you have to erase some part to use that. Yeah, it's very clear. If you are going to get this one, easily you will solve that. All right. That implies minus 2 into 0 minus 2 into 1 plus z is equal to 0. Minus 2 plus z is equal to 0. That implies z is equal to 2. All right, it's very clear. We would like to go for that. You have to write down. This is very clear. We would like to represent. So finally, you got that L is equal to f power 0, a power 1, t power 2. This is the case we have. So you can have the options and get the confirmation. This is very clear. So which is going to be the answer? First one is going to be the answer. In this way you can solve the problem. Please have the look into that matter and you can solve the problem. It's very clear. All right. Okay, in this way we can solve that. For any involved equation in terms of the base quantities, you have been represented one derived quantity in terms of the base quantities, the powers are going to be having the relation with the powers of that derived quantity. Just you have to take. So, the base quantities involved in the representation on both the sides, just you have to confirm. Okay, in this way we can solve the problem. This is a linear system of equations can be solved and get the value. All right, it's very clear. Now you can go for that. Yes, this is also one problem, just we have to solve this one, right. Okay, you have to go for that. If force F, work W and velocity V are taken as fundamental quantities. Yeah, generally we would like to go for that fundamental quantities, mass, length, time. Okay, if we have been choosing that the fundamental quantities are going to be force, work and velocity. Okay, yes, you have to take that given for fundamental quantities. It's very clear. Yes, you can go for that. They are F and W and V. Yeah, it's very clear. Now we would like to go for that taken as the fundamental quantity. Then the dimensional formula of the time, it is going to be, yes, you have to write down, that is going to be identified. It's very clear. You have taken this one. We know that, please write down. Yes, force and displacement and work done, all they are going to be represented. Work done is equal to force into displacement. It's very clear. That is going to be identified. This one, yeah. It's very clear. You would like to go for that. Yes, you can write down. Just they have given the answer. Okay, we would like to solve the problem. From the given fundamental quantities, you have to find out that any relation, any existing relation in terms of these F, W and V. Let us check. So, if you know that work done, it's going to be the force into displacement. It is very clear. So, you have to write down that force into displacement, that is going to be W, that is equal to, you have to write down force into displacement. It's going to be L. Displacement is going to be L. It's very clear. We would like to go for that. All right. It's very clear. Now, this is equation number 1. Yes, you have to rewrite. Yeah. That is equal to F into L by T into T. We are all going to write down. That's simple. You have to divide and just you have to take this one. This is very clear. We would like to go for this one. This is a simple modification. You have to multiply and divide with T. Yes, you know very well about that. That is going to be F and V and T. Since L by T is equal to velocity. It's very clear. So, L by T is equal to V. All right, it's very clear. You would like to go for that. Yeah, we would like to represent this one. Yes, this is the case. We would like to go for this one. Now, you can easily find out that, yeah, you can easily find out that W is equal to F V T. Therefore, what they are going to ask you? Yeah, the dimensional formula for time T. So, W F minus 1 V minus 1 is equal to T. Just you have to write down here. It's better for you. Yes. Yeah, you have to write down. Therefore, F minus 1 W V minus 1 is equal to T. Just you have to write down. That is very clear. You can place it T, that same one. Now, easily you will find out that. So which is going to be the correct answer? Let you know. This is very easy for you. Right. Therefore, T is equal to, in another way, dimensional formula of T is equal to, it's very clear, W F minus 1 V minus 1. It's very clear. So this is going to be the correct answer. Yes, you have to take this one. Yeah, this one is the correct answer. Fourth option is going to be the correct answer. You can check it. This is a simple and easy for you. All right. Okay, you can go for that and get the value. Easily you will solve that. Okay, from the given data you can solve any problem. If you want to get the dimensional formula of any quantity which is having the relation with the base quantities. Suppose you have taken that, if you want to get the dimensional formula of T, the base quantities involved force, work and speed. Just you have to take that force and work and velocity. You know, work done is equal to force into displacement. This is very clear. We would like to go for this one. This is very important relation to solve this problem. All right, it is easy for you to get the answer also. Right, okay. And at the same time you have to multiply and divide with that equation, whatever, just you have to get that. Okay. In order to get that, you know very well about that, V is equal to L by T. So, you know, force into displacement, that is going to be work done. You know very well F dot L. If you multiply and divide with T, that is going to be, yeah, that is the case, we have to get that L by T and T. Yes. So, FVT. In this way we will, you have to choose to derive that, yes, T. We are not at all going to be having the T, but you have to multiply and divide with the T. That's better for you. All right. Right, let's go for that, another one. Yeah, this is also one important problem. If the force F, mass M and time T are chosen as the fundamental quantities, then the dimensional formula for length. Yeah, force and mass, they have given that. It's very easy for you, just you can take that. Force F, okay, mass which has been taken M, okay, all right, and then you can take that time T. It's very clear, you can go for that. Or chosen as the fundamental quantities, then dimensional formula of length, then these are the base quantities. These are base quantities. You have to get this one. Base quantities. Yes, if you know, then dimensional formula of for length. That is the case, you have to choose that. From the 4 options, you have to get that correct one. Let us discuss that. Okay. Yeah. If you know that there exists any relation among that force, mass and acceleration, and which has been involved that length also, just you have to take that. It's very clear. Let's have the look into that matter. You have to take that. That is very clear. Oh. Right. We know that force is equal to mass into acceleration. Very clear. We would like to go for that. Mass into acceleration. This is the general relation, we are going to have that. So, you know very well about that. Force, it's going to be the F, mass, it's going to be that acceleration, this is going to be that L by T square. All right, if you are going to get that, yeah, that is F is equal to M L T minus 2. Okay. Yeah, if you are going to get that dimensional formula for length, okay, if you are going to get that F by M, just you have to take that, if you are going to write down this one. From the existing relation, you can solve the problem. It's very easy for you. If you know that there exists any direct relation, we would like to apply that. Otherwise, you have to multiply and divide with some other terms. All right, this is the best method to choose the formulas. Okay, right. So, you know very well about that acceleration. Yeah, if you are going to get that acceleration, that is going to be rate of change of velocity. Yes, if you are going to get that, yeah, that is d by dt of, if you have to get that velocity, you have to confirm, that is, you know, velocity v is equal to displacement by time. It's very clear. Now we would like to go for that L by T. So you are going to get that L by T, you have to get that. This is very clear. So you again you can go for that d by dt, just you have to take that. Yeah, you have to, just if you are identifying that relations, again you are going to get that, it is represented. So you will get that L by T by T, just you have to take that. It's very clear, you have to take that LT minus 2, right. So acceleration is going to be LT minus 2. If you are going to find out that dimensional formula for the length, yeah, you have to take that F into m power minus 1 T power 2 is equal to L. This is very clear. You would like to replace it. If you wants to get that, how we are all obtained that acceleration is going to be that L by T square, we have to confirm. So rate of change of velocity. If you go for that velocity, just you have to take it displacement by time. This is very clear. So we would like to go for that L by T. It's very clear. Now it's going to be F m power minus 1 T power 2. It's very clear. All right, it's very clear. Just you have to identify that. Yes, if you are going to take that, the base quantities are going to be the force, mass, time. It's very clear. Yes. Then the dimensional formula of the length. Yeah, we have chosen force is equal to mass into acceleration. You know very well about that, force is equal to mass by mass into acceleration has been represented in the dimensional formula, and we have been written that F is equal to m into L by T square. It's very clear. After that we have been solved, but this is the explanation what we are getting that. Yes, this is going to be the explanation for that, you are going to get that. So which is the correct answer? Let you know, this is going to be that F m power minus 1 T square. Yes, this is the correct answer. You have to get this one. All right. You need to know that option B is going to be the suitable for the dimensional formula of length in terms of force and mass and time. It's very clear. So in order to obtain this relation, you have to go for that existing formula, existing relation. Further, if you want to get that relation, if the quantity, the physical quantity which has been not involved, you have to multiply and divide with to obtain the derived quantity. Yes, yeah, you have to follow this procedure. Let's go for that another one. Yes, it's very clear, we would like to go for this one. The SI unit of a physical quantity is Yeah, you have to take this one. The SI unit of a physical quantity is joule meter square. It's very clear. The dimensional formula for quantity. The dimensional formula for the quantity is known as, yeah, just you have to take that. If you want to get that options, you have to take this one. This is very clear. We would like to go for that given data. All right, just you have to take that. Yeah, physical quantity. SI unit of physical quantity. You have to get this one. It's very clear. You can go for this one. That is going to be joule meter square. It's very clear. You can go for this one. Just you have to write down. That is J is going to be joule, M is going to be meter. It's very clear. You would like to go for this one. Okay, you have to confirm. Yes, joule is a derived unit to represent the energy. Yes, you have to take that joule and you can follow that. Yeah, let us take that 1 joule is equal to 1 Newton meter. It's very clear. We would like to get that 1 joule. It's a representation. Yeah, you have to take that Newton. It is going to represent the force. It is also that SI unit for that force. Yeah, it is that unit for force. Unit for force. So this is also unit for length. Very clear. You would like to go for that SI unit. Just we have to take that. Yeah, that is M. Yes, force. You have to take that. That is going to be that. Yeah, you would like to get this one. That is going to be force. Yeah, you have to take that mass into acceleration. Mass into acceleration. Very clear. And you have to get that meter. It's going to be that. Yeah, you have to write down. That is going to be meter. Okay, let's take that M into L by T square, and you have to take that. This is going to be L. All right, you are going to get that M L square T minus 2. This is for joule. Yeah, you have to confirm. It's going to be in the dimensional formula and the representation. It's very clear. So we are having that. Yeah, its dimensional formula is going to be taken as that M L square T minus 2. It is that energy. It is the energy. Dimensional formula. Does it represents the energy? Say yes or no. Yeah, you have to check it. It's very easy. Joule is the derived unit to represent the energy. It's very clear. What we have been obtained the dimensional formula, it is going to be the correct answer. No issue at all. Okay, we would like to go for that. Meter is going to be L. So if you are going to check that J square, yeah, you have to take this one. It's very clear. Now you have to take that joule meter per second square. That is going to be, yes, you have to get this. Yeah, that is M L square T minus 2. Yeah, you have to get that L square. L power minus 2. It's very clear. You have to take this one. M is equal to. All right. Therefore, you will get that M power 1, L power 0, T power minus 2. all right. Therefore, joule per meter square. It is going to be having the answer. Yeah, this is the case we would like to go for that, all right. Yeah. Okay. So, this is going to be the answer. You have to check it either A or B or C or D, just you have to see. This is going to be the correct one, right. Option D is going to be the correct one. Let's have the look. So, finally, we would like to go for this one. This is very simple question, but you have to define that joule and its representation, all right. You have to take this one, it's very clear for you. And if you are going to get this joule meter, it's going to be getting that joule is equal to Newton meter. It's going to be work done. Let's have that. It is going to be that work done. We have to take that. Work done is nothing but energy, or work done is going to be that potential energy or kinetic energy. Just you have to take. This is very important. So unit Newton, just 1 joule is equal to 1 Newton meter. It's very clear. So Newton, just we have to get that representation, force. Yeah, it is SI unit for the force. Now we will write down that dimensional formula for that force, mass into acceleration. SI unit for length, you can easily find out that. That is going to be the meter. That's going to be that. Yeah. After getting all these things, 1 joule. So if you are going to get that joule per meter square, which is going to be represented as, this is the case we would like to. So L power 0, we are going to get that. This is very easy for you. The dimensional formula for that physical quantity. If you know that joule per meter square is the units for a physical quantity. What about that? It's a dimensional formula m power 1 L power 0 T minus 2. This is the case we would like to get. Right. In this way we would like to derive. All of you have the look into that matter and you can go for that another one. It's very clear. Right. Let's go for another problem. This is also the similar one. Just you have to take that. Yeah. If you have seen that the last problem and its solvation, you have been identified that joule. Here they have given the time. Just you have to see. It's very clear. We can take that. It's a unit of. It's very clear. Yeah, you have to check all these things. Let's have a look into that matter. It's very clear. You know very well about that. Joule by second. It's very clear. Okay, you have to get that. Okay. Yeah, you can take that 1 Newton meter by second. Just we have to take. Yeah, you have to take that joule is equal to work done. That is going to be force into displacement. We have to see. This is very clear. We would like to go for that. All right. Just you have to go for this. Okay. Right. We would like to go for this one. Yeah. It is the unit for the work done. Let's assume. Okay. Work done by time, just you have to take that. Work done by, you have to write down. It is going to be represented by time. How you will confirm that? If you are going to get that it is a work done by time. So simply if you know that joule, it is going to be 1 Newton meter, it's very clear. Force into displacement, Newton, it's going to be the derived unit for the force, and then you will have the displacement is going to be that in meter, it's very clear, and you have to get that seconds, it is going to be the time. All right. Now you would like to go for that. Yes, this is going to be that power. It's very clear. So yes, W by T is equal to P. It's very clear, you know. Yeah, you have to take that. It's going to be that power. Yes, yes, just you have to see. This is the correct answer. If you are looking for that, yeah, energy, yeah, nothing is the work done is equal to energy. Yeah, you have to get this one. Work done is nothing but energy, but you have to take that it is divided with the time. Okay, it's very clear. So angular momentum, if you are going to get that dimensional formula, just you have to check it very clearly. If you are going to get that angular momentum, how you will check that? Yeah, you know, angular momentum is equal to the linear momentum of a body in case of the 2D or 3D motion is known as angular momentum. Generally, if you are going to get that, if a particle which is having that motion in a plane or in the circular path or in a three-dimensional space, then the momentum possessed by that body is going to be known as angular momentum. It's very clear. It is going to be perpendicular to the plane of that rotation or plane of which is going to contain that motion, right. So angular momentum L is equal to mvr, right. Here you would like to go for this one. It's not at all going to be suitable. Just you have to take that. It's very clear. Force into displacement. It is not at all going to be suitable. If you know that for the force, and you will get that just you have to check, right. So it's going to be ma into s. So m into v minus u by t into s. You have to get this one. Yeah, we would like to go for that. It's very clear. We would like to go for that. Yeah, power is the correct answer. The remaining are not going to be suitable. Let's check. Dimensionally we will verify. That is going to be mvr, that is m into L by T into L. That is going to be ml square T minus 1. It's very clear. But if you are going to get that work done, ml T minus 2 into L by T, that is going to be ml square T minus 2 T minus 1. That is very clear. ml square T minus 3. It's very clear. It's not at all going to be suitable for that. Now if you are going to get that power, it's very clear. With that power you will go for that stable. If you are going to get that momentum, it's going to be m into L by T. So that is ml T minus 1. So power, it is dimensionally we have been verified that it is going to be the suitable for that power. So joule per second is the unit of power. It's very clear. We would like to go for that. Why it is going to be unit for the power? Just it represents that dimensionally it is going to represent the power. Joule, it's going to be Newton meter. It's going to be equal to work done, that is force into displacement, work done by time, and we will get all these things. All right, it's very easy for you. Now work done by time, rate of doing work, it's going to be equal to power, and it has been verified dimensionally, it is correct. If you go for that remaining options also, it is not at all going to be the suitable one, right. Let's go for another one. Right, we would like to go for this one. If time t acceleration regarded as b, then the dimensional formula for the work. It's very clear. Work is equal to F dot S. So, ml t minus 2 into t. It's very clear. Yeah, time t and acceleration. It's very easy for you. You will get that. It's not a simple task. Then they are going to ask that A is the acceleration, force into displacement. Just you have to get that. You would like to go for this one. So, W, which is going to be m. Yeah, you can take that F into S. You have to get that, multiply with t square. Just you have to take that t square by t square. It's very clear. That is going to be F into A into t square. So, now we will get that. This is the method we can solve that. Okay, you have to take that F A t square. It represents the acceleration. Okay, in this way we will solve the problem. So, it's very easy for you. Okay, students, let us meet in the another classes. Keep watching. Thank you very much.